Today I'm a pirate. Well, maybe not really, just goofing around here. This is Mr. Lipscomb. I'm going to talk to you a little bit today, 8th graders, about the lesson from 8M5 Introduction. We covered it in class. And what we're going to specifically talk about is the concept of functions, inputs, outputs, ordered pairs, linearity, and proportionality. So let's skip over to our handy tablet, and let's look at an example that's something like what we worked on in class today. So the first thing we want to look at, these are two separate charts, T-charts or tables. These are two-column tables, and we're just going to look a little bit at each one at a time. So remember, we looked at these two today in class, and we identified some key things about it. So what we have is we have some what we have here is functions. And the reason we know that these are functions is because for any given x value, we have a y value, and we have there's no repeated x values. In a function, remember, any number that I stick into a function, I have to get a unique number out. So if I had a number here like 2, and over here I had a number like 0, then that would mean sticking in a 2 could give me a 0 or a 3, and then that is not a function by definition. I can only get one output, which is my y, for any input, which is my x. So I'm going to eliminate that incorrect piece of data before someone takes a screenshot of it and accuses me of making a mistake. So let's talk about what we have, a little bit further about what we have here. So again, in this function over here, and I don't know exactly what the function looks like algebraically. I just know what it looks like in this chart. And it means if I put in a 2, I get a 3. And if I put in a 4, I get a 4. And if I put in a 6, I get a 5. And so this is my function. Now, each of these things, remember, is called an ordered pair. So this 2, 3 is an ordered pair. These are, and we have 4, 4, etc., all the way down. And these are my ordered pairs. Ordered pairs. So let me erase all that right now. All right, we'll get rid of that because it's just going to be kind of clutter on our page here. And we're going to talk a little bit about, we're going to move over and we're going to talk about something that maybe is a little bit more interesting to you, which is whether or not these functions are proportional or not, and whether they are linear. Okay, as you recall today, we talked about proportions that are linear, or sorry, functions that are linear and functions that are proportional, and they're similar in some ways and different in others. So we're going to identify this chart here, and let's take a look at what makes this either a proportion or linear or neither. So the definition, if you recall, of proportionality says that whenever I go from when I have a change in x, I'm going to have an equal change in y. So here I have, I go +2, and here I go +2, and here I go +2. Let's just leave it at that for a second. And then from here, I go, for every time I go +2, I go +1. So from my 4 to my 5, I go +1. And so my 5 to my 6, I go +1. So you can see that in this chart, that by definition, this must be a linear function. Because equal equal changes in x yield equal changes in y. So we know that this is indeed a linear function. Let's look over here and decide whether on the right we have a linear function. And what you can do is you can actually pause this video and make a decision for yourself as to whether you decide this is a linear function. So what I'm going to encourage you to do right now is to pause the video and make a determination of whether you think this is linear by this definition. Okay, so now that I'm assuming that you paused and you did some math on this over here, and you made a decision about whether you think that this is a linear function or a linear relationship. And so let's just say that let's make these, and let's go and make these in green. And we're going to say, well, we go here and we go +8. This is +8 from 16 to 24. These are both +8. And from 2 to 4 and from 4 to 6, we go +2 and +2. Okay, now we have an interesting question here as we go from, so it looks linear so far because we have an equivalent +2 goes +8, and +8 +2 we go another +8. But the problem here is we go +4, and here we go +16. All right, so again, this is +4 as we make this jump. And so we have to make a decision about whether this represents still a linear function. And the way that we do that is we say, well, the growth in y over here is 8, and here it's 2, and here it's 8, and here it's 2. Well, here it's 16, but here it's 4. So the answer is that this is still a linear function, because a change here of 8 gives an x change of 2, and so that equals 4. A change of 8 here gives a change of 2 here, so that's 4. Right? So if I go, and now if I change this one by 4, this one goes by 16. So it still changes by 4 for every one. Right? So if I go 2 here, I go 8 here. If I go 4 here, I go 16. So you could probably determine that if I actually went, let's just say that I went up 1. So let's scratch out this 20 for a second, and let's go here. Let's go make this an 11. So now I'm just +1. This change here would be only 4, 44. Because then if we kept extending to 12, we'd go 48. Okay. I hope that made sense here. So the idea is you figure out how much y changes and how much x changes, and as long as they're changing by the same amount per x, we're still linear. Okay. So yes, this is also linear. And if this didn't make perfect sense, blame that on me. Maybe I didn't explain it that well. But we'll continue to do this, go over this in class over and over again. Now, there's a question of proportionality. And the question of proportionality says there's a difference. Once something's linear, it may also be proportional. If anything that is proportional must be linear, but anything that's linear may not be proportional. And the idea with the proportional relationship says, can I multiply every x by a same number and get to my y? Well, I think you can see over here that the answer is no. And maybe you can pause the video and figure out by yourself why that's true. But the number that I have to multiply 4 by to get to 4 is times 1. But to get from 2 to 3 is times 3 halves. So that's times 3 halves. And from 6 to 5 is 6/5, and 8 to 6 is times 8/6 or 4/3. And so this constant changes. So this relationship over here is not proportional. It is linear, but it is not proportional. On the right side, however, you'll see that to get from the left to the right, we multiply by a certain number. Here we multiply by 4. To get from 4 to 16, we multiply by 4. To get from 6 to 24, we multiply by 4. 10 to 40, we multiply by 4. And 11 times 4 is 44, and 12 by 48 is also 48. So this, because every single ordered pair, you can calculate the output by multiplying the input by 4. In fact, we can write the equation of that thing as y equals 4x. So anything that can be written in the form of y equals some number times x is proportional. This is another way to look at it. This is the algebraic way of looking at it. The table or T-chart way of looking at it is saying, hey, can I multiply the first column by a number to get to the second column? Either way is accurate. Now, the other interesting thing that you'll see about all functions that are proportional is that they must contain, if they have an x value of 0, the y value must be 0. So 0, if we look at the function down here, we say y equals 4 times 0. Well, 4 times 0 is 0, so it fits here. But we also see that it fits the pattern of, if you go from 0 to 2, that's a +2. And if you go from 0 to 8, that's a +8. So it does also match this pattern of adding 2 on the x's, you add 8s on the y's. On the other hand, over here, if you look at this relationship, you're going to see that if you put in this linear relationship, if you put in your 0 for x, our y value is going to be a 2, right? So we have +2 here and +1. So 0, 2 still fits the pattern and belongs in this chart, but because we don't have the number 0, 0 in our chart, we know also we can eliminate and say this cannot be proportional. It can still be linear, but not proportional. So I hope this lecture, this chalk talk, if you will, was useful to you. If not, please leave me some feedback. If you liked it, if you liked this video and it was helpful to you, please click the like button on Schoology. Look forward to seeing you in class next week, and have a super day.